Okay, we're going to solve the next exercise. The exercise is the number 1.25. The acceleration due to gravity at sea level is g equal to 9.81 meters per square seconds. The radius of the Earth is 6,370 kilometers. The universal gravitational constant g is equal to 6.67 times 10 to the minus 11 Newton square meters per square kilograms. Use this information to determine the mass of the Earth. So first, what I'm going to do here is that I'm going to get the result as fast as I can. Why is that? Because I'm going to start with an equation that actually is proposed by Isaac Newton, and I already know that some of you understand the equation and just wanna understand the exercise, but some of you also don't understand the fundamental physics behind this equation. So I want to make that straight for you guys, and I want to actually make all of you happy solving this exercise. So I'll start now. I'm going to use the equation that I just said, which is the acceleration on the Earth is given by the equation of g multiplied by m(e) divided by r to the second power. Alright, so this g is for the universal gravitational constant. This me is going to be the mass of the Earth. This r is the radius of the Earth, and this a is an acceleration, which is the acceleration due to gravity, which is this one. So what I have to do here is to recognize that I am missing this constant. I got this one, I got this one, and I got this one. So I gotta play with this equation and solve it for the me. So the me is equal to a multiplied by r to the second power divided by g. Alright, so here I have the 9.81 meters per square seconds multiplied by r, which is the 6,370 kilometers, or the same thing as having times 10 to the third power meters divided by g, which is 6.67 times 10 to the minus 11. Do I get that right? I'm writing that correct? Yeah, it is right. Newtons meters to the second power divided by kilograms to the second power. Alright, so, and let me get this to the second power because of the equation. Now I'm going to play with these units, so I know for sure that at the end of the equation I'm going to get a unit for the mass, which is in this case should be kilograms. Now I have right here meters divided by square seconds multiplied by meters to the second power divided by newtons multiplied by square meters divided by square kilograms. The first thing that I'm going to do here is to multiply this. Alright, maybe it's not that clear for some of you, so let me rewrite it. Meters to the third power divided by square seconds meters, sorry, newtons meters to the second power, and here I have kilograms to the second power. So I'm going to apply this law in which I multiply the numerator part of the first division, which I've circled in blue, and I'm going to multiply it by the denominator part of the second one. So that is meters to the third power multiplied by kilograms to the second power. And I'm going to divide that by the multiplication of the denominator part of the first division, multiplying it by the numerator part of the second division, which is seconds to the second power multiplied by newtons square meters. So the first thing that I could do here is to eliminate 2 of these 3 meters with these 2, and the answer at this point is meters multiplied by kilograms to second power divided by square seconds multiplied by newtons. So these newtons are meant to describe a force, and a force, because of Newton's second law, is equal to mass multiplied by an acceleration. So this is going to be equal to a meter multiplied by square kilograms divided by square seconds multiplied by kilograms multiplied by meters per square seconds, in which these kilograms means the mass part of the equation, and these meters per square seconds are describing the acceleration part of the equation. Then I could eliminate these 2 with these kilograms, and these square seconds with these square seconds, and these meters with these meters. So the final answer is and should have been kilograms. Alright, I did this because maybe in some future you'll have to play with these kinds of unit system, and you just have to get used to it to do it. Alright, so now I'm sure that I'm getting the units that I want. So I'm going to put the equation on the calculator. 9.81 times 6,370 times 10 to the third power, and this is actually to the second power. And here I have 6.67 times 10 to the minus 11. Alright, what happened? Times, I'm sorry, to the second power. Now, the answer is the mass of the Earth is equal to 6.9675 times 10 to the 24th power kilograms. Now, we have already solved the exercise, but where is this equation coming from? So on the Earth, and this is something that happens on the Earth, or maybe not just on the Earth. I'm sorry to formulate that the way I did. When you have two particles, there is going to be a gravitational force between these two. And let's imagine that this particle is the number 1 and the number 2, and are separated by a distance r. And it is important for me to analyze that this has to have a mass, and this particle has to have a mass 2, m2. So the force that these two particles are going to experience is going to be equal to the constant g that we have already managed, multiplied by the m1 by m2 and dividing those two by r to the second power. Alright, so in which this r is this same r. Now, when we talk about the Earth, which is a huge sphere, although the Earth is not a homogeneous sphere, we can't assumption. We could have an assumption with this concept and imagine that the Earth is spherical. So here I have, for example, the Earth, and I'm going to point the center of the Earth with this red point. Here I have the r. Here I have a mass that is on the Earth. All right. I'm going to call this mass m. And at sea level, because this value of gravity change with the height of the particle, the weight is given by this equation. So the weight is equal to the g constant multiplied by the mass of the particle multiplied by the mass of the Earth, because in this case the second particle is the whole Earth, me, divided by the distance between these two particles. All right. Now, an acceleration or actually let me explain this equation first. A weight is also a mass multiplied by an acceleration. Alright, and because of this, a mass multiplied by an acceleration is equal to g times m times me divided by r to the second power. I could send this m to divide the other part of the equation, and I'll eliminate the mass of the second object. So the acceleration could be solved, and that is going to be equal to g times me divided by r to the second power. Alright, now this works, and this is applied for an object in which the weight is the only force acting on it. This is the acceleration that the object will experience. Alright, and this is how we get to the equation that I've solved before. Which is this one. Alright, I hope you guys could understand what I've been trying to explain here. Maybe this is not the best way for me to explain this kind of information, because there is a lot of other videos in YouTube in which you can maybe see some different animations and some different ways in which you could understand these concepts better. But I hope, and this is why actually I just pretend to solve the equation first, to solve the exercise first, I'm sorry. But this is also pretty important. Alright, so this is how, guys, this exercise could be solved.